Welcome to this video. In this video, I'm going to talk about Introduction to Organic Chemistry. And this is your channel, Study by Yourself. The lecture is going to be done by, or the presentation is going to be done by Sir Prince. So, Introduction to Organic Chemistry. Organic Chemistry. So let's look at a fun fact about organic chemistry. You know, organic chemistry deals with organic compounds containing carbon. So, the origin of the name carbon comes from the Latin word carbo, for charcoal. So in Latin, instead of saying charcoal, we say carbo. So that is where the word carbon is gotten from. So what is an organic compound? They are compounds containing carbon atoms which are covalently bonded. This means that there are certain compounds which are not covalently bonded but have carbon in them. These ones are not organic compounds. So let's look at compounds which contain carbon but are not covalently bonded, or they don't fall under organic chemistry. Now we have cyanides. Cyanides are bonded ionically. We have sodium cyanide for the first one here. We also have hydrogen cyanide. So we have carbonate, calcium carbonate, and then sodium hydrogen carbonate as well. Then we also have oxides, carbon dioxide, carbon 4 oxide. Although they contain carbon, are not organic compounds. And we also have carbon disulfide. Carbon disulfide is not an organic compound. So let's continue to look at the difference between organic and inorganic compounds. We've mentioned that organic compounds contain carbons and they are covalently bonded, but we have inorganic compounds which contain carbon which are not covalently bonded. So first of all, let's look at properties of organic compounds. So carbon is always present. Carbon is always present for every organic compound. Carbon is always present. So they are mostly covalently bonded. They are mostly covalent bonded. They are highly volatile. Organic compounds are highly volatile. Example is using a perfume. Because there is alcohol in a perfume, and alcohol or alkanols fall under organic compounds. When someone with a perfume passes by you, you can smell it. Why? Because the organic compound in it is volatile. They are soluble in organic solvents. Let's assume you have something which has soiled your attire, but the thing is made up of organic compound, organic solvent, organic solutes, like let's say the oil paint. When the oil paint stains your attire or any part of your body, you need an organic solvent to dissolve it. Example of organic solvent can be turpentine, which can be used to dissolve the paint. They have low melting and boiling point. Organic compounds have low melting and boiling point. Let's compare water to alcohol. We know that alcohol boils at a temperature of 78 degrees Celsius, but water boils at a temperature of 100 degrees Celsius. Yes, their reactions are also slow. So let's look at the contrast in organic compounds. So carbon may be present. As I mentioned earlier, carbon may be present, but it is not an organic compound. And I said these compounds are not covalently bonded. So they are ionically bonded. Ionic bonding refers to the complete transfer of electrons. And then covalent bonding refers to sharing of electrons. So in an organic compound, electrons are being shared, but with an inorganic compound, electrons are being transferred from one element to another. Specifically, the positively charged elements or ions are transfer electrons to the negatively charged ones. So they are most are less volatile. So comparing water to alcohol, alcohol is more volatile than, because you can smell it as well. You can smell alcohol. So they are soluble in inorganic solvents like water. So an example of inorganic solute is salt, sodium chloride. Sodium chloride will dissolve in water. It means that sodium chloride will not dissolve in an organic solvent like turpentine. So they have high melting and boiling point. So comparing water to alcohol, water has a higher melting and then boiling point. So their reactions are fast. Reactions of inorganic compounds are fast. So let's look at another fun fact. Carbon exists in all living organisms. All living organisms contain carbon. All living organisms contain carbon, meaning plants, animals, microorganisms, they all contain carbon. That is why organic chemistry is worth studying. So what are the main sources of organic compounds? We have coal. Coal was a source of fuel used in trains, but as a result of technology and progress, coal is not used in modern trains or used as a source of fuel. The disadvantage of using coal is that coal generates a lot of smoke, which pollutes the environment. So crude oil. Crude oil is a very essential commodity in the world now because through fractional distillation, petrol, kerosene, coal tar, natural gas for cooking, wax, bitumen, they are all gotten from crude oil. So the third source of organic compound, we have plants. So plants, the protein, foods, the carbohydrate, the fiber, the drugs, they all contain organic compounds. Animals, the wool of certain livestock, enzymes, hormones, they all contain organic compounds. So other organic compounds include ethine, ethane, ethene. Now these organic compounds, we are going to look at them into details. So don't worry about their names. So another fun fact. Pure carbon is non-toxic. Now when I was talking about coal, I mentioned that coal produces smoke. It means that the smoke has been mixed with other elements. So that's what you see as smoke. But pure carbon is non-toxic. Why carbon has a tendency to form many stable compounds? If you are watching this video, I believe you might have seen certain structures where carbon is connected to another carbon, very long, connected to another hydrogen, oxygen, nitrogen, or any halogen. Now, why is carbon able to form so many stable compounds? So one, it is tetravalent. One, tetravalent. Carbon being tetravalent, it means that it has 4 electrons on the outermost shell. Since it has 4 electrons on the outermost shell, it can form bonds with more elements. It can form a single bond, a double bond, a triple bond with carbon atoms and other elements like chlorine and so on. So since it can form a double bond, single bond, I'm going to talk about single, double, and triple bonds more in the next video. So they can form a straight chain, branch chain, and a ring. You are going to see all these in the next video. So this diagram you are seeing here is showing you a straight chain. This is a straight chain. Okay, so let me show you again. This is a branch chain. You can see that it goes up and it comes down. Yes. So that's why carbon has a tendency to form many stable compounds. So the next thing is a homologous series. When you hear the word homo means the same. Homologous series. Now, they are a family of organic compounds. Now, this family of organic compounds have a general formula. This general formula helps us to identify them and also name them. So, the homologous series is given to a family of compounds which consists of a series of compounds. So they have a general formula and they differ in series by units of CH2. This means that when you pick the series which is next to the other, it differs by CH2. So when you pick one compound in a series, the next one, the one which is immediately after the first one, differs by CH2. In the next video, it's not going to be a presentation. It's going to be where I'm going to demonstrate and draw, and as well as after watching the video, you'll be able to name. So they include hydrocarbons. Now hydrocarbons include alkenes, alkenes, and alkynes. So alkane has its general formula. Alkene has its general formula. Alkyne also has its general formula. So we have alkanoic acids, alkyl alkanoids, alkanose, fats, and oil. All these I've mentioned have their general formula, and also we have something which is called functional group, which I'll talk about. So types of hydrocarbons. Hydrocarbons are organic compounds which contain hydrogen and carbon only. So as the name implies, hydrocarbon, hydrogen and carbon. So when you see any organic compound which does not contain, which contains hydrogen, carbon, and others, for example, are not hydrocarbons. So these ones you are seeing down here are, these are organic compounds. They are hydrocarbons because they contain only hydrogen and carbon. So we have types of hydrocarbons. We have saturated hydrocarbon, the organic compounds which are bonded covalently with a single bond. So any organic compound you see with only a single bond, just the dashes, just one dash between the carbon and then the other elements, say hydrogen, they are called alkanes and they are called saturated hydrocarbons. So the unsaturated hydrocarbons, they contain either double or triple bond. So you see 2 dashes or 3 dashes between the carbon and the other elements. So those ones are unsaturated hydrocarbons. We're going to look at identification of organic compounds or hydrocarbons. So how do we identify an organic compound or hydrocarbon? What is the test, or what are certain processes you are supposed to undertake in order to know that what you have is a hydrocarbon or not? First of all, you need to know that hydrocarbon contains hydrogen and then carbon only. So these are the elements of importance. So first of all, what you do is you grind an organic compound into powder and add 4 times as much powdered carbon 2 oxide and mix well. So let's assume you have say 2 grams of the powder. They are saying 4 times. So 4 times of 2 is 8. So you are going to add 8 grams of copper 2 oxide and then you mix well. Now you might be wondering here how you are going to get the hydrocarbon. An example of hydrocarbon is camphor or naphthalene balls. So if you are in a science lab where you have access to the chemicals for the test, you can perform this test. So the second one is put the mixture in a glass tube and heat. Put the mixture in a glass tube and then heat. So a gas will be evolved. So what you are supposed to do is you are supposed to pass the gas through lime water as well as anhydrous copper 2 sulfate. But I wanted this to be more interactive, although it's a presentation. So I was like, why should the gas be exposed to the 2 substances mentioned above? And I said the clue is that the gas is exposed to oxygen. So I believe by now you might be having thoughts running in your head. What lime water is used to test for and what anhydrous copper 2 sulfate is used to test for. Okay, so with the knowledge you have in science, you will know that the lime water is used to test for carbon dioxide. So if lime water is used to test for carbon dioxide, since there is carbon in a hydrocarbon, it means that during the heating process, carbon is going to react with oxygen to produce carbon dioxide. So the lime water is going to test for the carbon dioxide. So hence it is testing for the carbon, because without carbon, you cannot have carbon dioxide. Also, anhydrous copper 2 sulfate is used to test for water. So since you have hydrogen also in a hydrocarbon, it means that the hydrogen is going to react with oxygen to produce water. So this water is what the anhydrous copper 2 sulfate is going to test for. So hence you are testing for the hydrogen. So if you are testing for any chemical or any substance and you don't have carbon, the carbon is not going to mix with the oxygen to produce carbon dioxide, as well as the hydrogen is not going to react with the oxygen to form water, so that the anhydrous copper 2 sulfate reacts with it. Now, in our last slide, we are going to look at how to test for unsaturated hydrocarbons. And in the previous slide, I mentioned that unsaturated hydrocarbons are hydrocarbons which contain 2 bonds or 3 bonds, or double bond and triple bond. So you can see alkenes and alkynes here. Alkenes contain double bonds, alkynes contain triple bonds. So how do you test for an unsaturated hydrocarbon? Bromine water is brown. Bromine water is brown. Now, when bromine water comes into contact with an unsaturated hydrocarbon, it becomes colorless. It becomes colorless. So let's say you have an alkane and then you have An alkane is a saturated hydrocarbon. So bromine water is used to test for unsaturated hydrocarbon. So unsaturated hydrocarbon, I said, is either an alkene or an alkyne. So when you pass bromine water through, when you mix bromine water with alkene, the bromine water will still have its original color. But when you pass the bromine water through the alkene, which is an unsaturated hydrocarbon, the unsaturated the mixture will become colorless. The mixture will become colorless. This is the introduction to organic chemistry. I'll urge you to subscribe to this channel if you've not done so. Hit the notification bell so that when I upload a new video, you'll be notified. I'll urge you to just stick to this channel because I'm going to drop how to name the hydrocarbons and then their chemical properties as well as their physical properties and their sources as well. Until then, keep studying by yourself. Thank you.